What is Jugalbandi? According to Wikipedia, a Jugalbandi is a performance in Indian classical music, especially in Hindustani classical music, but also in Carnatic music, that features a duet of two solo musicians. The word Jugalbandi means literally entwined twins. The duet can be either vocal or instrumental. So, welcome to Pratidhwani Humanizing Science. I'm your host, Pawan Kumar. Today's podcast is about Jugalbandi, especially in the context of research. There are many metaphorical Jugalbandis in research, especially in scientific research. And in this podcast, I will discuss about Jugalbandis in research and how they actually can affect the way we do research at all. So one can look at the interaction of science, scientists, and society in various different ways. And my goal in this podcast is to just give you an overview of how we can understand science, society, and how people do research, generally speaking. So let's get started. The first and the most interesting part of Jugalbandi, the Jugalbandi number one, is the Jugalbandi between the experiments and the theory. You see, when you perform an experiment, generally speaking, you are looking at something in reality. Historically speaking, experiments were supposed to be a direct connection to the natural philosophy. In fact, if you look at the origins of the thought process of how science is done, this was the basic question people were asking. Very interestingly, there was a lot of emphasis given on observation. In the context of doing an experiment, there's a fundamental difference between observation and just seeing, okay? Because seeing can be just visually kind of noticing some specific thing, but observations go beyond this particular seeing aspect. Now, crucially, as science evolved, and the history of science tells us very elegantly that in addition to looking at the nature, one can also analyze the nature. So one can actually extract some meaningful information from whatever you have gained, and then look at this particular interaction in the context of mathematical processes and mathematical analysis. So therefore, theoretical analysis becomes equally important along with the experimental viewpoint. If you look at various different peoples from 1600s down to, let's say, to 2023, there are celebrated theoreticians who are looking at how science is done. Take, for example, Newton. Newton was a person who did both experiments and a lot of theoretical analysis. And he brought these two thoughts very well together. In an essence, he was always playing this Jugalbandi of experiments and theory, and they were going hand in hand. And interestingly, if you look at also another very famous physicist whom we all respect and celebrate, is Albert Einstein. Einstein is, of course, known for his relativity theory and photoelectric effect and various different interesting questions related to quantum mechanical principles. In fact, he also questioned the fundamental foundations of quantum mechanics. But there were very interesting works, what he did, which was also closely related to experimental physics. And he did collaborate with few experimentalists. And many of the questions he got were motivated by very interesting experiments. So this aspect of looking at the whole universe, so-called physical universe, from a mathematical viewpoint is extremely important. In fact, it adds a very important layer to the conventional observations what we do in experiments. So therefore, the Jugalbandi between the experiments and theory is one of the most important things in the pursuit of science. An equally important aspect, which was very beautifully highlighted in a 2012 essay by Freeman Dyson. Freeman Dyson, as you probably would be aware, was a celebrated physicist, mathematician, and also a very interesting scientist who looked at the society from a very particular viewpoint, which is in sync with what we do in our podcast. He was also trying to humanize science. And in 2012, he wrote a very interesting essay titled, "Is Science Mostly Driven by Ideas or by Tools?" So in that particular essay, he makes a very interesting comparison between Thomas Kuhn's famous The Structure of Scientific Revolution, 1962 work, which gave the scientist a viewpoint of how scientific revolutions happen. He compares this with another book which was published in 1997 by a physicist turned historian who was an experimental physicist turned historian by name Peter Gallison. And the book name is Image and Logic. And that is a very interesting viewpoint, what Dyson mentions, that Gallison brings in a viewpoint as an experimentalist and teaches us that the way we look at science and the way science is driven is not only through the ideas, which is essentially from an experimental viewpoint, but also from a theoretical viewpoint, which was equally emphasized by Thomas Kuhn. So to quote Dyson, broadly speaking, the first half of 20th century belonged to Kuhn, and the second half to Gallison. Kuhn and Gallison are both excellent historians, but each of them depicts a partial view of science. We need both of them to give us a complete picture. Stop quote. So what he is telling is that you need not only theoretical ideas, but also important experimental tools to play this Jugalbandi between the experiments and theory. So that is the Jugalbandi number one, which is quite important and interesting while doing science. Now coming to the next Jugalbandi, which is the hedgehogs and foxes. You know hedgehogs and foxes. These are two interesting animals. But in 1953, there was a very famous essay written by philosopher Ishai Berlin, and the title of the essay was The Hedgehogs and the Fox. This was essentially motivated by the Greek philosophy, where the thought process goes on the following lines. A fox knows many things, but a hedgehog knows one big thing. So this is something you will find extensively while doing research, You'll see somebody who is extremely well trained in a particular technique or one particular idea, and that person makes significant contribution in that particular idea. An equally interesting and a slightly different viewpoint is somebody who is very good at few things and who is able to bring these things together in a very interesting way. Such people generally are called as foxes, and the hedgehogs are the ones who really focus on one big particular idea. In order to take the science in the forward direction, you need this Jugalbandi between hedgehogs and foxes. You need people who can think broadly, and you need also people who think deeply. So therefore, this kind of amalgamation, again, in terms of bringing their thought process together, is one of the important aspects of doing research. So while doing scientific research, people have very different skills and very different kind of trainings. So therefore, bringing them together on one platform is very important. Now, if you look at, let's say, people who really are interested in one particular aspect of a problem and want to go deeper and deeper into it, then what is important is to venture into the depths and the details and also the rigor in which that particular depth and detail are kind of extracted. Some of the very famous scientists are like Marie Curie. She did outstanding work and she was extremely focused on the problem she was working on and really went in depth into the problem what she was working on. The other person who comes into my mind is Michelson of the Michelson-Morley experiment fame. Michelson, all throughout his life, and this was for a very significantly long period of time, he really was interested in measuring the velocity of light with higher and higher accuracy. So his experiments probably stretched over a period of more than 40 to 50 years, and he was always trying to improve the value of measurement of velocity of light. That tells you that somebody is really interested in one idea and they dedicate completely to that particular idea and want to venture into the idea in significant depth. And that is one viewpoint. The other viewpoint is to connect and bring big picture into the thinking. Such thinkers are very, very well known. Einstein was one of the great examples. Enrico Fermi was another person who not only thought about big problems, but also was very good with his hands. He was one of the rarest of rare characters because he could do fantastic experiments and also bring very insightful theory on the similar platform. And he's one person I'm going to talk a lot about in my podcast going in future, Enrico Fermi. By the way, I should mention that I dedicated my PhD thesis to Enrico Fermi because I am extremely inspired by the way he did science, especially physics, because he had a very beautiful kind of balance between this experiments and theory. And therefore, what I'm trying to tell is there is an important jugalbandi which happens between people who are going in depth and looking at the problem, one singular problem in extreme significant detail, and the other person or other people would be interested in looking at the problems from a slightly bigger picture. And both these viewpoints are extremely important. And Berlin's essay very beautifully kind of looks into this particular viewpoint. Anyway, I'm giving all the links in the notes. So I would be actually giving all the references. So do look up, and there is something great for everybody to learn from and understand. Now this encompasses Jugalbandi number 2. Now we go to Jugalbandi number 3, which is a question of novelty and significance. You know, whenever you send out a paper for review, especially a journal, and if it is an original paper, these 2 points are always important to be emphasized upon. And you will always find all journals make judgment on a research submission based on whether the work is novel and whether that has any specific significance. So novelty tells you that what is new in that particular work. Please remember that when we talk about novelty, nothing is coming out of thin air. This is something which is very important for us to recognize, because not everything what we do in research is a complete kind of reinvention of a wheel. So we get inspired by ideas which are already existing. We test those ideas in the laboratory or in theoretical framework or computational analysis, and look at the new ideas from a viewpoint of mixing old ideas. And this is something which is very, very critical. So if the new mixture of ideas is creating some interesting direction which was otherwise not thought of, that is where the novelty is. So therefore, in that sense, novelty is very critical by combining 2 existing ideas and creating some new direction and emphasizing that while we do research. The other part is also to look at the landscape of ideas and try to connect them to something which is contemporary and something which is very important. And this is always a very crucial thing when one does research, to ask how does the work what one is doing is important in the context of something which is contemporary and which is significant to the field. In this specific context, I would want to quote a very famous essay and a talk given by Richard Hamming, and the title of that essay is called as You and Your Research. Hamming was a very celebrated coding theorist. He was in Bell Labs for a very long time, and he interacted with a lot of great people, including Claude Shannon, who gave the information theory. And he beautifully tells about the importance of working on problems which are extremely significant to the contemporary research. So this is always a dilemma when you are working on scientific problems, to ask yourself whether I should work on something which is very important only to me or which is also important for the whole community. I would say it is always better to have some kind of an overlap between them. There is no point in working on problems which may not be interesting to you, but may be interesting to the community. And the vice versa is also sometimes not very easy for you to get published or really get your ideas out. Therefore, I always think that one should work on a problem which has a good overlap of personal interest and also a community interest, so that there will be some kind of a jugalbandi again. So Hamming in his essay makes a very interesting observation, and he tells, you see again and again that it is more than one thing from a good person. Once in a while, person does only one thing in his whole life, And we'll talk about that later. But a lot of times there is a repetition. I claim that luck will not cover everything. And I will cite Pasteur, who said, and he's citing Pasteur here, luck favors the prepared mind. So to again quote the author Hamming, and I think that says it is always that I believe that there is indeed an element of luck, and there is also sometimes no luck. The prepared mind sooner or later finds something important and does that. So yes, it is luck. The particular thing you do is luck, but that you do something is not. Stop quote. What he's trying to tell is that the choice of the problem determines whether you actually have an element of luck associated with that. So it is like being at the right place at the right time. So if you're working on the wrong problem in the right place, you might actually not get a lot of attention. Whereas if you actually are working on a right problem at the right place, and also it drives the point very clearly to the community, then you might actually end up getting some kind of an attention to the research what you're doing. And this is something which is very interesting and has to be thought through as we progress. Now, going to the Jugalbandi number 4 is to look at long-term thinking and short-term doing. This is something which is very fascinating, because long-term thinking in research is very critical. Think about it. Research problems like climate change, sustainability, public health, or economics, these are all things which are very, very important in the long term, and it has to be projected into the future. So what you do now will have a specific consequence, let's say few months from now or few years from now. This is something which is extremely important and always plays a very critical role. One is looking at the problems in research. So therefore, one will have to balance or bring in a very nice jugalbandi between long-term thinking and short-term doing. When we talk about short-term doing, the importance of processes become very critical. The implementation of the questions and the problems in the field or in that particular arena is very critical. You see, complex problems like planning a city, requires not only a very good kind of elaborate plan, but one needs to also implement the policies in very specific detail. And therefore, balancing out the long-term thinking and the short-term doing is extremely important, because how you do what you do at the present moment will significantly affect the trajectory of the problem what you are doing in let's say a month from now or a year from now. So in this context, there is a beautiful article written by a system biologist. His name is Uri Alon. He's a scientist from Weizmann Institute of Technology. And he's written a very interesting article, and the title of the article is How to Choose a Good Scientific Problem. So in his abstract, he writes, quote, "Choosing good problems is essential for being a good scientist. But what is a good problem? And how do you choose one? The subject is not usually discussed explicitly in our profession. Scientists are expected to be smart enough to figure it out on their own and through their observations of their teacher. This lack of explicit discussion leaves a vacuum that can lead to approaches such as choosing problems that give results that merit publication in valued journals, resulting in a job and tenure." Stop quote. So what he's telling is that what kind of problems we choose, either in the short term or the long term, is not something which we generally discuss in general scientific research arena. For example, the kind of stuff what we discuss in our lab most of the time happens to be associated with experiments and theory what we are trying to develop. But what Uri Alon is telling is that we should also give a lot more thought on understanding how we choose a particular problem, in what way we would be able to look at the problems in significant detail. So one of the things he mentions in this essay is the following: take your time, associate at least 3 months to making a choice to the problem. And in that process, you should find among the problems available the one that is most feasible and most interesting to you rather than others. A good project draws upon your skills to achieve self expression. Stop quote. So, what he is trying to tell is that when you're starting a research project, try to spend some time with that particular problem. Don't totally commit to that problem. Play around and look at what are the feasible features of the problem, and then after a while take a leap and start working on the problem. In fact, I would urge you to have a look at this beautiful essay which I'm going to link. It is a gem. It is very, very famous too. A lot of people are aware of this particular essay, which is something all young people should read. Not only young people, anybody who is doing research would benefit from looking at this. So this is the Jugalbandi number 4, where long-term thinking and short-term doing plays a very specific role. Going to the Jugalbandi number 5, mixing the past with the present research. This especially highlights the importance of history. There is a joke, especially in the laboratory, and it goes like, a week in the lab can save you a day in the library. I'll repeat, a week in the lab can save you a day in the library, which means that if you do not do a background research of a problem on which you are doing work, especially in the context of experimental work, which needs elaborate planning and also design of the experiment, if you have not done a kind of a kind of preparation to that particular problem, then you might end up going in directions which might not be fruitful. So therefore, before really committing to an experiment, it is always better to go back and check what people have already done, and then judiciously choose your method and the kind of problem what you're looking at. So many problems generally have already been solved in a different context, or at least many researchers would have thought about the problem what you're thinking on, maybe from a different angle. This is very, very important. Okay, and there's huge amount of literature which is already available on any problem which you are getting started on. Of course, you should not get overwhelmed by the amount of literature which is already present. But what I'm trying to tell you is that there is always a significant room for one to go back and check what has been already done, which means that you should go back and check the history of the problem which you are working on. I will again quote Steven Weinberg's famous 4 golden rules. Among them, one of the rules he explicitly mentions is to go back and check the history of the problem. So I'll quote him. The history of science can make your work seem more worthwhile to you. As a scientist, you're probably not going to get rich. Your friends and relatives probably won't understand what you're doing. And if you work in a field like elementary particle physics, you won't even have the satisfaction of doing something that is immediately useful. But you can get great satisfaction by recognizing that your work in science is a part of history. Of course, stop quote. Of course, this particular viewpoint is telling you that it is important to go back and check the history, and that will give you a context in which you are doing the work. And I should mention that particle physics has turned out to be extremely useful. We have been able to really get a very deep peek into the universe by looking at some beautiful experiments which have been done over a long period of time. But what Weinberg is saying is that go back and check what has already been done. It gives you a kind of a lineage in terms of how human history can influence the thought process and how it can influence the problem on which you are working on. It will give you a very broad context. And this is something I am a very, very kind of strong advocate of. I feel that one should actually have a deep interest in the history of the problem one is working on. That gives you very interesting insight into the problem. And therefore, the Jugalbandi number 5 is to mix the past with the present work, what you're doing. Now let's go to the Jugalbandi number 6, which is the biggest Jugalbandi one can actually have, and that is the Jugalbandi between science and technology. You see, knowledge is produced first as a curiosity, as a small question, and there is a continuum of knowledge. What starts as an idea can lead to a specific question. That question can lead to some kind of an observation or a theory. And that observation or theory can give you some interesting answers. And those interesting answers can lead to further questions. And those questions can lead to some interesting answers. And it goes on and on. What is interesting is that if you are now looking at this as a lineage or some kind of a hierarchy of ideas, then what starts as a curiosity ends up within the laboratory circumstance as a prototype or a device, for example, let's say. Now, that is where a particular researcher, especially a basic researcher or even a research engineer, would be looking at the problem from the viewpoint of a prototype, for example. Now, there is also another way of looking at the problem. And that angle is to look at whatever is going on in the research arena, be it in theory or in experiments, and ask how does the society look at that particular problem. So this is giving you a different angle, you see. So it is a society which is trying to pick a particular solution which is already available and utilizing it for its own benefit. This is where engineering plays such a critical role. And this is where an important aspect called as ergonomics plays a critical role. Ergonomics essentially is to design something for human use, and engineering's knowledge is very, very critical in that. So the prototype is the stage up to which a laboratory scientist or a theoretician would actually be able to bring her or his idea. It is now kind of a different angle through which the society would have to take that idea and go further. And this is where entrepreneurs, engineers, and people who would want to actually diversify their viewpoint will come into picture. And this is an equally important viewpoint because that is how a lot of benefit to the society has emerged over the past several decades. But this also brings in a question: to what extent does a scientist who is working in a lab, can she or he be able to contribute to, let's say, manufacturing? Because manufacturing is a problem which is not only about prototyping, but also requires various different steps which will take this idea and scale it up to a large extent. Therefore, economics plays an important role, societal needs plays an important role, and various different factors also come into picture. Which means that the viewpoint what one has to take is slightly different from a viewpoint, say, idea to prototype. So idea to prototype is the domain of basic researchers or research engineers, and the entrepreneurs and some engineers who are interested in kind of spinning off their ideas, creating a startup, would be wanting to look at this viewpoint of societal needs and taking the idea further. So this aspect of idea, observation plus theory, prototypes, ergonomics, manufacturing is a continuum of idea. This is very important for us to recognize that each kind of individual and researcher contributes to the chain of this idea. You might not be able to contribute significantly, let's say, to a fundamental problem if you are an entrepreneur. Similarly, if you are a very specific kind of an expert in an area and you have many ideas and experiments which are working in the laboratory, you might not be able to work out the problem of manufacturing. This is where a continuum is necessary, and this is where society, science, entrepreneurship, various different factors come into picture. And that is where it also becomes very interesting how ideas evolve as a function of space and time. In 2011, two American scientists, very, very well-known scientists, George Whitesides of Harvard and John Dosh from MIT, wrote a very provocative article in Nature, and the title of the article was "Let's Get Practical." They were mainly targeting their article towards chemistry audience, especially chemistry researchers. They were trying to motivate them, telling that chemistry has to move in a direction which becomes a little bit more practical. I find some specific aspects very interesting and very pertinent, although I should mention that it is a bit controversial too. But one of the things which I really liked is what I'm quoting now. Start quote. One should try to reorganize and solve problems that are important and recognizable to the society that is paying for the research, especially those to do with water, food, health, energy, and environment. To make fundamental discoveries, an approach that starts with practical problems and uses them to reveal unsolved fundamental problems will work at least as well as, and arguably better than, one that starts with the familiar questions of familiar disciplines. Stop quote. What Whitesides and Dosh are arguing is that you can look at problems which are there already in the society and pick specific unit of a problem which can be connected to a fundamental question which you are comfortable with. This is something one should all think about, especially people who do fundamental research. Generally, one of the criticism we face, including myself, for example, sometimes, is that what is that which you are doing which is significantly translational? What is that which is totally impacting the society directly? So this is a point which all of us can get motivated by, where we can think about some problems in the society which can be connected to some of the fundamental questions we are interested in. So that connection is not easy because it would require a deeper thought process, but there is something to really think about in this particular direction. And it is surely worthwhile to understand the Jugalbandi between the science and technology. So what I have discussed are the 6 Jugalbandis. Okay, so I have discussed Jugalbandi number 1 between the experiment and the theory, where each of them play a very interesting role. I also discussed in the second Jugalbandi about the hedgehogs and foxes, who play different roles and bring in their own thought process in understanding the universe and the research problems. The third Jugalbandi in science and research is novelty and significance, which is very important and which will make an impact on the work we do. The Jugalbandi number 4 is the long-term thinking and the short-term doing. So bringing them together is extremely important. The Jugalbandi number 5 was mixing the past with the present, the role of history, and which plays a very critical role in that. And finally, the Jugalbandi number 6 is the Jugalbandi between science and technology. So these are the 6 Jugalbandis, and by no way they are exhaustive, but these are some things which I thought are interesting in the context of the research what we do. So bringing things together always creates something interesting and new. So in the context of music also, this is very important. All of us probably are aware of a very famous song, especially in India, which is the Mile Sur Mera Tumhara To Sur Bane Hamara. So this is a famous song where a lot of artists sing beautiful songs in various different languages, which showcases the diversity and also the multilingual nature of Indian society. Similarly, the Jugalbandi, what you can find in science, is essential not only to do good science, but also it is important to humanize science. After all, you see, Pratidhwani is all about resonance of sound and hopefully a resonance of scientific thoughts. So what I can say in conclusion is, let there be Jugalbandi of science, and of course, let there be Pratidhwani of science. See you.